So a little bit about me. I have over 20 years of experience in the tech industry. During those last 20 years, I've worked in a variety of roles from IT systems administration, QA, software engineering, architecture, and management. I've been at DigiCert for over 10 years, and in the last 6 years, I've been working in engineering management. I have a bachelor's in mathematics and a minor in computer science, and I'm almost done. I'm in my last semester of an MBA program at the University of Utah. And when I'm not working or schooling, I love traveling with my family. And when we're traveling, 99.99% of the time is to Disneyland. It's a little uptime humor. About DigiCert, it was founded in 2003. We're a world-leading provider of scalable SSL, IoT, and PKI solutions. DigiCert secures more than 28 billion web connections every day, and the headquarters is in Lehi, Utah. We're a global company with over 1,500 employees around the world, and 250 of those are in our engineering organization. DigiCert has a pretty large customer base, and that customer base includes 89% of the Fortune 500 companies and 99 out of the top 100 global banks. DigiCert is a leading provider of digital trust. Over the last several decades with DigiCert, they've made a number of acquisitions. And in 2017, DigiCert acquired Symantec's web trust business, and it over quadrupled the size of our company. We went from about 300 employees to 1,500. During the last several years and over these acquisitions, we've worked on consolidating all these products into a unified platform called DigiCert One. DigiCert One is part of a trust ecosystem. It's a digital trust platform. And with this platform, we can integrate the installation and management of digital certificates on user devices for securely authenticating to corporate resources, sending secure emails, and digitally signing documents. Also, with this same platform, we can automatically install publicly trusted TLS certs on web servers and load balancer. With the same platform, we can also secure IoT devices. These are very critical use cases for our customers, and we need to have it up and running 24/7. So if we rewind a little bit back to DigiCert 2020, 2021, I'll just say it, we have outages. Our customer and products are growing at a rapid rate, and it's putting strain on our systems. And we have some of our key customers and partners complaining and escalating to our executive team about these outages. And as I mentioned, our product portfolio is a mix and match of products at different levels. We had our legacy products that have existed since the beginning of DigiCert. We had new products we were developing, and some of those through acquisition. And some of our key legacy products in particular had more downtime than they should. So at this time, we decided, during those years, we decided to kick off a high availability project. We called it the HA project, and the goal was to increase our uptime to 99.99%. I would say we didn't have a great handle on what our uptime was, but a good estimate was 99.5%. And so what that meant is we had to go from 3.65 hours of downtime to less than 5 minutes per month. And what I want to share during this talk is a retrospective of 3 lessons we learned that I think had the biggest impact of decreasing our downtime. And I give each one of these lessons a name, kind of a theme to help motivate the concept. The first one is called One Giant Leap. Don't go too big. The next one is the domino effect. Cascading failures can cause big outages. And finally, cliffed out. Bad deployments can cause long-running outages. So one giant leap. We right off the bat, we wanted to go big. We started with the assumption that the only way to achieve higher uptime was by doing active deployments, which meant our applications needed to be running in multiple data centers at the same time, so that failures in one data center wouldn't impact the customers. The traffic would be routed automatically to another data center. We knew from where we were standing this was going to be a lot of work, and we needed uptime ASAP. So where did we start at this project? Just to give a little context, we were a pretty good place with our global data centers. DigiCert had data centers located around the world in US, Europe, Japan, and Australia. These data centers were configured in a production and disaster recovery configuration. And all of our data centers were fully redundant at the physical layer, so they were fully redundant power, servers, and networks. A couple of notes about our disaster recovery site is they wasn't as big as our production site. They didn't have the same level of compute power and could not handle 100% of the traffic. Also, we didn't have all our real-time data available in our disaster recovery site. It mostly held backup data. And the last point, which is key, is that our application architecture was set up in such a way that it could only run in a single data center. So if we needed to fail over to our disaster recovery site, we had to shut down one instance and spin it up in our disaster recovery site, so only one instance of our product was only running at a time. So we got to work, and in the next couple of quarters, we made some big progress. We added compute power to our disaster recovery sites. We set up real-time database replication, or nearly real-time, between our production and disaster recovery sites. And we took extra steps to automate our deployments in both of those locations. And this was already a lot of work, and we'd already spent a fair amount of time on it, and we still had one big issue. We needed to re-architect our products to be able to work in multiple data centers, and we still needed to deal with big architecture concerns like eventual consistency and event-driven design. This was going to be another large project on top of what we already invested, and we decided to settle on a different strategy at this point. We said we're going to go active-passive. And with that, we're going to still run our apps in a single data center, but we would reduce the amount of time it took to flip from one data center to another. So in summary, the good news is, with this project, we were in a much better place to handle a disaster in our production data center. We could flip from one data center to another in less than 30 minutes. But the bad news is this was still way too long to achieve our uptime goals, and we didn't address our root cause, or the root problem. So this was a giant leap, and we needed to readdress the problem, think more iteratively, and use data to address our immediate downtime issues to get quicker wins. So nothing fancy here. We went back to the basics, the fundamental metrics, and we still had the main goal of 99.99% uptime, but we added additional metrics around how long did it take us to detect that outage and how long did it take to recover. And with these, the goal was to get real accurate measurements on these. So how did we go about increasing the accuracy of our uptime? What we did is in each of our web service products, we built RESTful endpoints. We call them extensive health checks. And we called these REST endpoints, they ran a battery of internal checks. They made sure that the web service was up and running, database was healthy, external dependencies were up and running. And if any of these checks failed, this endpoint would return an error code. And we could hook these endpoints up to our global monitoring system called New Relic, and it had the ability to run these synthetic checks from multiple locations around the world. And if any of these checks returned an error, we would start getting measurements, downtime. It would start measuring our downtime in seconds. And we could build a dashboard like this where we could now trend our uptime from the last month, last quarter, last year. And this really increased our accuracy. Now that we had this, we were able to pinpoint outages with these endpoints. Once a week, when we would detect these problems, we would log a JIRA. And this JIRA, we could do a root cause analysis. And with that root cause analysis, we would log things like what was the cause of the outage and what was the action we took to resolve it. And again, with a dashboard similar to this one, we were able to trend over time to say, we see a lot of cascading failures. A lot of our outages are caused by some system causing a failure in another system to cause a failure in another system. And a lot of the time to resolve these, we needed to roll back whatever change was introduced at the time. So that gets us into our second lesson, the domino effect. How do you prevent one outage in one system from causing an outage in another? And how do you potentially prevent one user from bringing down all of your systems? So this is illustrative of an outage that we would see kind of the makeup of an outage, where one customer would call our product, in this case it was MPKI 8, and this request would send off a long-running query. And the customer wasn't making a lot of these requests, but they made enough of these that eventually locked up the thread pool and consumed all of the resources on the MPKI product. Secondary to this, another product, DigiCert 1 DTM, relies on MPKI 8, and because it was returning slow, it was also starting to show outages and issues. So what happened here is that effectively one customer was able to bring down all of these products and affect multiple customers at once. So about a little over 10 years ago, I read this book called Release It. And in the first chapter of this book, the author describes a scenario when he worked for an airline where they released a new version of their booking and ticketing system. And that change also had a long-running query issue. And eventually, a few users was able to bring down this airline's whole ticketing booking system, causing a lot of chaos and panic for this airline. What this author learned over time is that there's ways to prevent these type of outages. And he identified 8 stability patterns. And a theme from the book is that a degraded user experience is better than a complete system failure. So what we did is we assigned this book to all of our engineering teams, and we made it a quarterly objective and said each of the teams must read this book, and by the end of that quarter, be able to apply these different stability patterns to our products. Now I won't go into all of these patterns in detail, but if you haven't read the book, I highly recommend it. But these patterns have names like timeouts, circuit breakers, bulkheads, steady states, fail fast, etc. So at the end of that quarter, we had each of our teams generate an architecture diagram at a high level. It looks like something like this, where they took their product and mapped out all their external dependencies. And what we wanted to see is that based on these dependencies, be able to identify and label patterns that they could use to prevent these kind of outages in the future. So for example, with MPKI 8, they should have failed fast or timed out those queries to prevent that thread pool from being consumed. With all that data, with the architecture diagrams and the data that we generated from our outage reports, we were able to focus on some key patterns, and one of those was the circuit breaker. And the circuit breaker sounds, it's like it sounds. If you're in your home and a circuit breaker trips, electricity is no longer running through that circuit. In a similar way, if you use this in your product, if your downstream application's down, it will prevent, the breaker will trip and it will prevent that application from calling that. To speed up the adoption of these, we used open source libraries like Resilience4J. And once we had all these in place, we were able to, again, create a dashboard that showed the state of these circuit breakers. And when one was down, we could easily pinpoint where the outage was. And this helped us considerably reduce our time to detect and time to recover from an outage. The final lesson, so several years ago, we had to migrate from one database technology to another. And this was a big project, and this would actually require some downtime. So we needed to do this during the maintenance window. And so to reduce the impact on our customers, we made the choice to do this like midnight on a Saturday. And we promised our customers and our business that this rollout would not take more than a couple hours. So we went ahead and got started, and we were doing the rollout. And right away we were experiencing some issues. Some unexpected issues. We were troubleshooting, and we knew this was going to take longer than a couple hours that we'd promised. So as a team, we agreed that we need to roll back. So the team went off to work, and 10, 15 minutes later, I asked the team, how's it going? Is the system's coming back online? And they responded and said, the rollback's not working, and it's not going to work. So our only choice was to roll forward. And what should have been a 2-hour outage turned into an over 24-hour firefight. Obviously the CEO heard about this, and when I went in the morning to tell him what had happened, he told me I was cliffed out. And I wasn't familiar with the technical term, and he described that it's a situation where a rock climber will come down the mountain, rappel down the mountain or descend down a mountain, and they'll reach the end of the rope, and they're no longer able to go down or back up. They're cliffed out. They're just stuck in the middle of the cliff. So at this time, most of our products, at a high level, our system design looked like this. We had a Kubernetes cluster, and it was connected to a load balancer and a database cluster. The way we did rollouts is we did a rolling Kubernetes deploy, and the changes could be introduced into production without any customer downtime. But what we didn't have is any way to verify these changes worked, that there was no production configuration issues or production runtime issues before we put customers live onto these systems. So this system design didn't have a quick way to roll back to a known good state, and we needed a more comprehensive rollback strategy to prevent from getting cliffed out. So what we decided to do was I guess what you'd say is a typical blue-green deployment. In our production environment, we had our version 1 Kubernetes green cluster, and then we added a blue cluster for future deployments, and V2 deployments. We made some changes to our load balancer. We made it very easy to switch between one version of the cluster or the other, so that when we wanted to do a deployment, we could just switch to the blue cluster at the load balancer level. But in order to make this work, because we had one database cluster, we needed to be able to support running multiple applications, multiple versions of our product in production at one time. So we needed to make sure any of our changes that we made, any database changes, needed to be backwards compatible, along with our web service. Any integrations between web services, those API changes need to be compatible too. Once we got this in place, we were able to accomplish 2 different things. So now, when we did a deployment, we did all of our changes to the blue cluster, and we could run those. We could run a suite of automation tests and verify that there was no production configuration or production runtime issues before we put customer traffic on there. So we were able to prevent a lot of those type of outages before they even occurred, because we could fix them before they were live in front of our customers. Also, second to that, if we happen to switch our customers over to that new cluster, we could immediately, within seconds, switch back to the known good state. So this had a big impact on reducing our mean time to recovery. So how did this all work? What kind of impact did this have on our products at DigiCert? What I'm showing here is some very high-level stats. This is an aggregation of all of our product outages across. So an outage is across all of our products, just rolled up into these numbers. And in 2022, we identified 23 outages that resulted in just under 6,000 minutes of downtime. Versus 2023, we had 32 outages, but I would say we were a little better at detecting outages. But you can see the real impact here is that we had a third of the downtime. So it really did make a significant difference. So in summary, the lessons were one giant leap. Don't go too big. Try to find steps that provide immediate value to your company when it comes to uptime. So use data, and small incremental changes can have a big impact on uptime. The second is domino effect. Use the release of patterns to prevent cascading failures. And finally, cliffed out. Don't deploy code without a comprehensive rollback strategy. Thank you.
Awesome. Thank you so much, Wade. Really appreciate it. I think there were some pretty cool lessons in there, that actually unique lessons. I have never seen a situation where that you recommend that your teams read a book and basically tell them like, hey, they need to do this, and that's how we're going to improve our team. A lot of times it's kind of like you need to dedicate that time, like as an engineer, you need to dedicate that time on your own without like leadership telling you. So it's pretty cool. I'm actually curious, while we let questions come in through Slido, we have one, but I'm just curious, like what brought you to that? Like, have you seen that done before?
The book? Or?
Yeah, like recommend it, like, have your team like read a book and
no,
be
not specifically.
You guys apply this.
Yeah, no, I hadn't. I mean, I've worked at companies where we did brown bag lunches, we did book clubs, and we did those kind of learnings. But I think we were in a situation where we wanted to, the book had the answers. There was some really big similarities between what the book had described and what we were seeing. And so, yeah, we made it an objective. And honestly, at first there was not really a big adoption. But once we made it a quarterly objective and said, you need to show us a diagram, an architecture diagram that you've proven that you understand these patterns and that you can apply them, then everybody got really interested.
Got it. Yeah,
so it was kind of a take-home test.
All right. So we have one question in here. How do you define downtime?
Our definition of downtime in this case is based on those external health checks. So when we developed those and we put a lot of scrutiny on those health checks that say, because there could be the problem, there has been, where they don't detect an outage. And if they don't, we go back and we look at those checks and we say, okay, we need to add some more logic in here to make sure that we can detect these kind of outages. And so, and it's on a service-by-service basis that we define that. It's not at the whole product. So we break it down to all of our individual web services. Got it.
Makes sense. All right, cool. Let's go to the next one. Did you use observability tools to log, monitor, or trace? Or maybe which ones did you use?
So we use Splunk and New Relic extensively as our tools. And so some of those dashboards that I was showing were New Relic data and dashboards that we built from New Relic, and then others were based on Splunk. So we do, we log everything to Splunk, and if there's any issues raised in there,
Got it.
Those bubble up into our dashboards.
Makes sense. Cool. All right, we have a ton flowing in here. Give me a second. Let's see. Okay. Great point about cascading failures. Do you have a service catalog that maps dependencies, or are your services monolithic enough that this isn't necessary?
I would say we're a service-based architecture, although some of our legacy products are definitely more in that monolithic category. So what we did with this architecture diagram, so it is complicated enough that we can't just, it needs to be broken down. And so what we did is that there's different, we have 3 different engineering organizations, and we made each VP of engineering responsible for generating an architecture diagram for their department. And then even it went down even lower into each team level. So that's how we did it. Is we basically broke it up and made it,
and then like put them all in one big PowerPoint slide.
Well, no, we did. You're right. Actually, no. Now that I'm thinking, we did do that. We had one big PowerPoint, and each team we went team by team by team, where they would show their diagram, their dependencies, and some would obviously overlap with others, but that's what we did.
Got it. Yeah. Okay. I guess I have some decent intuition. All right. So let's see. The next one is. Why did you decide to go after 99.99% versus 99.9, 99.95? Was this business driven? How did this impact your product service pricing?
It didn't impact our pricing specifically, and I think the goal was arrived for the fact that we wanted it to be a big goal, but we do have some of our customers that we're part of their workflows. If we're down, like an IoT manufacturer, if we're down, that can shut down their manufacturing line. So we wanted to go big and aim big, and there was some customer expectations driven behind that.
Got it. Yeah. And I guess then that probably ties into the next question, which is, how did you convince management and make a business case for it? Because, well, the impact of it is so large, I'm guessing. Yeah,
so the business case, early on in the slides when I was talking about DigiCert a few years ago in 2020, is that we were getting enough, our customers were getting loud about it. And so it got the attention of the business, and they came to us and said, we need to make these changes. And we had the luxury there of, saying, okay, let's make this a project and kick it off.
Got it. Makes sense. All right, cool. We probably have time for one or maybe two more. Let's see here.
I love this next question.
Yeah, same here. All right, I'll read it out. Blue-green deployments are awesome, but sometimes complicated by DB schema changes, especially if the DB is large. Have you ever run into this? Any strategies you would recommend?
Yeah, there is a bit of an art to this, and that's why I called it out. When you're running multiple versions of your product at the same time against one database, is you really do have to make sure those changes are backwards compatible. And one of the main strategies that we look at is that additive changes. If you're deleting a column or changing the data in a way that it doesn't work in both versions, then we don't want those changes. We'd say, go ahead and add a column. If you need to add a new feature, add that new column. And then you kind of treat it like a feature flag. In the future, you go and clean up those changes. So you kind of do it in a programmatic way, in an additive way. Over time, you don't make it in just one discrete rollout. Sometimes these take multiple rollouts to make those complete database schema changes. But you get the benefit of being able to immediately roll back if you hit an issue.
Yeah, that makes sense. Yeah, I know I have experience doing similar things like with GraphQL. GraphQL is like, there's only one version. So if you need to rename something, you need to make a new one. Then you need to put all the endpoints to the new one. Then you need to delete the old one. Then you can rename the new one.
Yeah. So you have to, it is a mindset shift for your engineering teams, because sometimes they're used to just hey, I'm dumping my new schema change out. I'm going to have Flyway migrate it. And then you're like, well, no, you got to actually break this up into maybe multiple releases to be able to accomplish the full change.
Exactly. Okay, sweet. I think we are just at time. Let's go to our last question we've been doing to all speakers. What's one book, and maybe it's it's that one.
Release it.
Yeah, what's one book that you would recommend to the audience that changed the way you work?
The one I'm most proud of is a while ago I read a unit test book that was over 1,000 pages, and I got through, it was about all the different patterns of unit testing. And
do you think it covered them all?
It covered them all, and I was proud that I got through the whole thing.
So what was that what you would actually recommend?
It's called X Unit Test Patterns.
Oh, okay.
It was a good book, but in all seriousness, it helped me write way better unit tests.
Yeah.
But I liked the lean startup, all the movement around that really changed how I thought about what my value was in building code and deploying it to the organization. That my changes are not valuable until they're in production, and that I should do the minimum viable things to get them out into production and tested. Along those lines, there's a lot of other books like the Phoenix Project and others that talked about these concepts as well. So I liked that.
Yeah, awesome.
Vein of books.
Yeah, I love that. Well, yeah, great. It was really awesome having you, Wade, and it was an amazing talk. I learned so much. Yeah, let's give it up for Wade one more time.